Alrighty then, folks. Let me do a quick mic check once this shows up on the other computer here. And oh no, well that's things are a little weird. Let me get my webcam in here. Video capture device. Yeah, there we go. There's me. Let's make me a little smaller. Okay, more or less good. I seem to be fine there. Let's check the sound. Oh yeah, speaker quality is awful, but that's what it is. We're starting a little late today on Advent of Code. It's about 11:30 p.m. So we'll keep track of our time from there. Start at 11:30, day 17. Pyroclastic flow. Your handheld device has located an alternative exit from the cave for you and the elephants. The ground is rumbling almost continuously now, but the strange valve bought you some time. It's definitely getting warmer in here, though. The tunnels eventually open to a very tall, narrow chamber. Large, oddly shaped rocks are falling into the chamber from above, presumably due to all the rumbling. If you can't work out where the rocks will fall next, you might be crushed. The 5 types of rocks have the following peculiar shapes, where hash is rock and dot is empty space. So all 4 across, a little plus, a little L, 4 things up, and a square. The rocks fall in the order shown. First the hyphen shape, then the plus shape, and so on. Once the end of the list is reached, the same order repeats. Hyphen falls first, 6th, 11th, 16th, etc. The rocks don't spin, but they do get pushed around by jets of hot gas coming out of the walls themselves. A quick scan reveals the effect of the jets of hot gas will have on the rocks as they fall, your puzzle input. For example, suppose this was the jet pattern in your cave. The jet pattern left means a push to the left, while right means a push to the right. The pattern means the jets will push a falling rock right, then right, then right, then left, then left, then right, and so on. If the end of the list is reached, it repeats. A tall and vertical chamber is exactly 7 units wide. Each rock appears so that its left edge is 2 units away from the left wall, and its bottom edge is 3 units above the highest rock in the room. Its bottom edge is 3 units above the highest rock in the room, or the floor if there isn't one. After a rock appears, it alternates between being pushed by a jet of hot gas 1 unit, in the direction indicated by the next symbol in the jet pattern, and then falling down 1 unit. If any movement would cause any part of the rock to move into the walls, floor, or a stopped rock, the movement instead does not occur. If a downward movement would have caused a falling rock to move into the floor or an already fallen rock, the falling rock stops where it is, having landed on something, and a new rock immediately begins falling. Drawing falling rocks with an @ symbol and stopped rocks with a hash, the jet pattern in the above example manifests as the following. Gets pushed to the right, falls 1 unit, push to the right but nothing happens, falls 1 unit, push to the right but nothing happens, falls 1 unit, gets pushed to the left, falls 1 unit, causing it to come to rest. A new rock begins to fall, jet of gas pushes rock to the left, rock falls 1 unit, jet of gas pushes rock to the right, rock falls 1 unit, jet of gas pushes rock to the left, rock falls 1 unit, jet of gas pushes rock to the right, rock falls 1 unit, causing it to come to rest. A new rock begins to fall. The moment each of the next few rocks begin falling, you would see this, and then this, and then this, and then this, and then this. We're building like a big weird shape. Okay, I get it. To prove to the elephants your simulation is accurate, they want to know how tall the tower will be after you get to 2022 rocks have stopped, but before the 2023 rock begins falling. In this example, the tower of rocks will be 3068 units tall. How many units tall will the tower of rocks be after 2022 rocks have stopped falling? To play to identify yourself. Okay, give me 1 second. I'm just going to full screen if I can figure it out. I'm just going to full screen my face. Let me transform. Where is this? Fit to screen. Okay, you guys just get to see my whole face so that we don't leak my login credentials here. Let's make sure the music keeps playing. Okay, so now I'm logged in. We're doing great. And we can go back to not just my face now. Fantastic. Okay. So I'm on a new computer. Let's go to levels. This is level 17. Level 16, I don't think it made it to GitHub. Did it? It did not. Okay, well, level 17, that's fine. It says today we need to add a new file. Level 17 data.txt. Yes, please do add this to Git. And new file. Level 17 problem statement.empty. Fantastic. Also add that to GitHub, please. Okay, wonderful. We don't need that. We basically just need these things, and I did have to modify follow a thing level 17 part 1. Fantastic. This needs to be something something something. Control F15. Nope. Control F. Actually, Control R. L15 needs to be replaced with L17. Replace all. Wonderful. Cool. So now we should be reading from the right place. So let's look at the test input now and see how that works. Get your puzzle input, which should be it's just a really long list of. Okay, cool. But that's all it is. So actually don't even need to do the while here. And I'm just having so much trouble. Let's put the stuff we care about on the right side. There we go. String instruction list equals Skinner.nextLine. And let's oh no, this is the wrong one. Let's copy the test input rather than the real input. Real input's too long. Okay. There it is. Let's put this in here. Looks great. For int I equals 0, I is less than 2022, plus plus I. So there's the number of rocks. So now it's got to be what? In new rock. And correct spot. Simulate. And let's go back to this. Let's figure out what the order of the things are. Let's go to here. Okay, so push, fall, push, fall, push, fall. So while I'm not entirely sure yet, simulate wind push, simulate fall, break if could not move down. True. I'm trying to think. Trying to think of like the minimal representation here. Do I want to like okay, so let's private static final int height equals, I don't know, call it 10,000. Private static final int width equals 7. Figure out where new rock should start. And then after all of this, we want to move down, put rock in. Alright. So now we want is it Boolean height width. That's what I'm looking for. That's the wrong kind of brace. Same here. Man, my hands are freezing cold. I'm at a lake house right now. Call it column equals new. Okay, well we need to just cut these, and it needs to just be this, and then this needs those. Fantastic. We've done it. They should all be null. So let's read the instructions on where the thing gets inserted. Actually, come back to this first. We want I'm thinking that we want like a rock. We want like we want like a class to represent this rock, and then we can just ask the rock, given the grid, can you be here? You know, can you get pushed right? Can you be here? Can you get pushed left? Yeah, that seems good. So let's do that. Oh, good, and this is still legible. Static class rock. This is probably an abstract class. And then we also want like private static class rock generator, private static rock generator instance equals new rock generator. We want rock generator. We want this to be private. Come on, private rock generator. Because we're making a singleton class, and then we want probably also want a private static int which rock equals 0. This should return a rock. Actually, first we want rock generator get instance, return instance, and then we want rock get next rock, and this is going to do some stuff. We want switch, want rock, and then we want switch which rock, return the right rock, and then we want which rock plus, and then we want return rock. Let's make sure that music's playing. Play me more music, please. Thank you. Yeah, that's fine. I don't care about that. Abstract class rock has void move, which takes in a character, and a. Do we want the rock to take in a grid, in a position? Yeah, that's what the rock's gonna need to take in. And then it'll initialize its own X. So that's fine. In fact, why don't we make this an interface? So abstract and static don't matter anymore. Abstract interface, move, character, direction, Boolean drop. Those are really the only two things that need to happen in the rock interface. And then we want private static class. What are all the rocks called? Let's move this here. Let's grab this. And let's look at the rocks and name them. Okay, this needs to be way smaller in order for this to work. And it's behind my face. Okay. So let's just put some notes down here at the bottom. Let's do this so you guys can see what's going on, and then we'll delete these. Great. So we have this rock, we have, in fact, let's just copy these. Copy, paste. Okay, those are the rocks that we've got. So let's name them real quick. Horizontal rock, plus rock. Let's get the capitalization correct here. L rock, vert rock, square rock. Great, cool. So those are our things. Now that we have those, we can go back to this. And so now we want static class, horizontal rock, implements rock. Yes, you're gonna get mad. Alt enter, implement methods, implement them all. Fantastic. And we're gonna copy and paste this 1, 2, 3, 4, 5 times. Horizontal rock. What are all the other ones? Plus rock. L rock, even though it's a backwards L, that's fine. Square rock. Oh no, am I out of rocks? Oh no, we just had 2 horizontal rocks. Okay, let's take this one and move it down to the bottom, and this can be our last rock. And we'll figure out the things for this. Horizontal plus L. Did I miss vert rock? I did miss vert rock. Okay, so this needs to go here, and this matters because vert rock. There we go. So now I want to take these and I want to put them rock with shape. Let's copy this and do this for all of the classes, just so I can have some good notes for myself as I go through and implement this. So now we need plus rock, which is more like dot hash dot hash 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 dot hash dot. Wonderful. This is rock with shape. This dot hash dot dot hash. This is rock with shape. Just 4 verts. And then this is rock with shape. Hash 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 hash. Is that right? Oh no, and backwards L rock, it's not from the top, it's from the bottom. Glad I copied that. So this should be dot dot, and this should be hash hash. Okay, cool. So now we can get rid of our notes here at the bottom. And I'm going to want to reconcile that again later to make sure that it's the case. So now we want, need constructors for each of these. So horizontal rock is going to take a Boolean array grid, call it that, and an int height. Although we can figure out the height from the grid, but let's do that. This dot we want private int height equals private int x. So we don't even want height, we want y. X. And then, is that really all we need? I think that might be all we need. So let me read this real quick. Rock shapes fall in the order shown, blah blah blah. It's exactly 7 units wide. Rock appears so that its left edge is 2 units away from the left wall. So this one starts in column 2. So horizontal rock always starts in, let's see, this dot y equals height. We also need to hold on to, play the music please. Private Boolean array. I want to check the sound again, this is weird. Okay, we're good. And sorry for all the creaking. I know that you guys can hear when I move my headset. Grid. Let's put these in order. This dot grid equals grid, and then this dot x equals oh, and I want to make oh crap, I want to edit this thing. I think that the interface rock shouldn't be Boolean. It should be yeah, we want this to return an int. Yeah. So let's just do this. If we see, I don't know. If we see this, int drop, replace all. Great. Yeah, that's fine. We'll fix them one by one. This dot x is 2. So that's fine. Let's take this. In fact, let's take all of this, and this is pretty much going to go on each of these rocks. Plus rock. Okay, this is plus rock. Same thing's going to happen. I need to turn this down. It's just a little too loud to think. This is going to be a really long night. This is not a trivial simulation. Revert rock, and we needed to go back through and change the x's for these. Copy. Nope. And paste. Square rock. Okay, so now we go back through. Got all our little rocks here. Horizontal rock is in fact 2. This rock, do we always want to think of the x's? 2. Yeah, and then we can, the rock is always, so like whether or not we can go left or right, like we're going to define ourselves here. Oh, but like the y is here. Oh, that's weird. Oh, this is annoying. Okay. I think I figured it out. We're always going to talk about the bottom left corner of the shape. So xy always refers to the bottom left corner, so it's always going to be 2, and it's always going to be height. So in this case is, yeah, what, 0, 1, 2, 3? Yeah. Great. So this is fine. And then we just need to do a bunch of tedious checks against like the grid. So move. Move is just left and right, so it's just whether or not we change the x. So we need to like, if direction is this, we need to do one set of things, else if direction is this. Can we please add a parentheses here? Thank you. And that's going to be the same everywhere. So if the direction is left, let's see. For rock with shape this, if x is 0, then we just return. For this one, if grid x minus 1 y is true, return, so we're hitting the left edge. Otherwise, x equals x minus 1, and then we return. In fact, we'll just x minus minus. There we go. And now we want to do this same set of things, but for the other side. And the checks are just going to get more complicated. So x is 6, width minus 1, return. Grid x plus 1, y is true, return, because that's, oh, but it's not x. If x is width minus 5, right? Because this can be at 0, it can be at 1, it can be at 2, it can be at 3. So if x is at 3, which is width minus 4. Play the next song, please. Thank you. Too loud. Yeah. So if x is at width minus 4, return. Otherwise, if grid x plus 5, right? Because we'd be at 3. So here we're at 2, and we want to see whether or not 7 is there. Yeah. Because that'll determine if we can't move to the right, and then otherwise we want to go x plus plus. Cool. So now we need to drop. Let's add some notes here. The rock moves itself the given direction, if possible, and this is let's add another enter here. The rock moves itself down and returns -1. Otherwise, returns the height of its highest element. Should probably spell highest correctly. Cool. Yeah, cool. So now for this we want to drop. If y equals 0, return 0. Otherwise, inserts itself into grid and returns the height of its highest element. That seems fine. So if 0 we're going too far here. We're just doing the top one right now. And drop if y equals 0. What we want to do is we want to say Boolean x y equals true. Boolean x plus 1 y true. Sorry, it shouldn't be equals. What am I doing here? Thank you. This is gonna be x plus 2. This is gonna be x plus 3. Sorry, grid, not Boolean. Oh. You can tell I'm tired. It's been 4 hours driving today after work. Else if grid x y minus 1, or no, we just want to make the same check. So x plus 3. If there's something below it, there's all this manual formatting. we go. It should be x+1. That would be a bug. Grid x, yeah. There we go. I probably want to make these conditions into like a little subfunction, like that's okay. Else, we can move down. Y minus minus. Return -1. Okay. That seems fine. So we want get next rock into Y. Case 0. Something. Case 1. Case 2. Case 3. Case 4. Plus which rock percent equals 5? Does that work? Rock equals new horizontal rock. Grid Y. We want Boolean. Grid. Play more music. Thank you. Yeah. Let's look at them. So, plus rock, L rock, invert rock, square rock. There we go. Default. Tab exception. Okay, next rock. Failed. Okay. There we go. Thing. So when we go back up here, I'm gonna rename this grid. And I'm also gonna say rock generator. Rock generator equals rock generator dot get instance. Did I make get instance private? No. Yeah, okay. Static. There we go. Better. So we want int y equals 3. Rock generator dot get next rock grid y. Rock equals rock generator get rock. Direction 0. Simulate orange push, which is going to be rock dot move instruction list dot get, or no, it's care at winds direction plus plus in direction percent equals. Actually, it's just like wind direction equals wind direction plus 1% insertion list dot length. Great, that seems fine. Fall equals rock dot drop. If fall is -1. Alright, what do we set about? We could not move down. Okay, great, cool. Very good. Rock could not move down. Fantastic, cool. So this all seems great. We just have to like code the other rocks and then just return y. Actually, we don't need an int fall. We just need y. And then we need to just, actually, it should be 0. Y plus equals 3. That seems better, because you want to start 3 higher than the bottom. Does that look right? Yeah, there's only 3 lines here. We're great. Great, excellent, cool. Let's simulate some more rocks. Actually, let's get rid of this stuff for a second. Let's just return new horizontal rock grid y. And we're going to take all of this stuff and just go like this for a second. And I want to see if we just can insert a bunch of rocks correctly without messing with all this stuff. So let's go here. Turn -1. Take me to the next one. Yes, yes, I created all of you erroneously. It's my fault. Be mad at me, compiler. Much better. Debug. Oh, it's not gonna... I didn't put any breakpoints. Well, it did finish. It simulated real fast. So what I want to do is I want to... Nope, nope, nope. Too high, too high, too high. Oh, we want to go... here. Sure. Actually, let's go here. And then if we get tired of doing all this part, we can just wait to the next breakpoint. Go there. The system cannot find the specified file. Well, that's probably because the file that we created has the wrong name. Nope. Refactor, rename. Refactor. There we go. Alright, now debug, please. Okay, so we're good right now. And our grid is just a gigantic list of things. Cool. And what's nice is that it starts at 0, actually. That's great. So we'll go here, we get our new rock, which has height 3. Let's delve in and see if it does the right thing. So it's moving to the right, which if we go back up to part 1, the first thing it does is move to the right, so that seems correct. And we do have space to move to the right because we would be in 1, 2, 3, like 2, 3, 4, 5 out of 6. And that's not true, so we move to the right. Then we return. And we simulate a drop. So y is not 0. And yeah, all of these things are false, so we're cool. So y minus, return -1. Y is still -1, so we're cool. Let's keep going through. Okay, so now when we get here and we look at grid. Grid. It blows to the right all the time, so it should be like, well, 0, 3. Is that right? Something like that. Oh, did we do XY? God damn it. It's supposed to be YX. Ugh. YX. Just terrible. This is always what gets me. The math notation and the programming notation are just always backwards from each other. Let's put the Y in. What do all these? Let's put all the -1s here, and then we can delete them in a second. I know, you're not a triple grid. It's okay. Yes, that's why you're weird. And we could make it go the other way, but I don't want to. It seems natural to me that this is how the thing goes. Okay, that's better. And so now we just need to reverse them here. Glad we checked earlier, rather than coding this up 5 more times and then having to change them on every single one. That's why you test, folks. Stop and rerun. Okay, we're there. Let's play through to there. Oh no. Two plus 5 is 7. It should be 2 plus 4. Okay, that's fine. Stopping playing music. Okay, so play. Now if we go to the grid, got a bunch of trues in there. Is that the right spot? Yes, it should be one to the right. So now if we do this again, in fact, if we stop here, we go to here. Plus Y. Cool, so let's stop and rerun it, and this should give us 2022, because they're all horizontal rocks. 2021. Okay, so that's... We'll see if we have an off by 1 error, but it should be fine. To prove the elephants in your simulation, you want to know how tall the tower will get after 22 rocks have stopped before the 23rd. Okay. I want it to tell me how high it is. It's not telling me how it like counts height. If any movement will cause any part of the rock to move into walls, floor, or a stopped rock, the movement instead does not occur. If a downward movement would have caused the falling rock to move into the floor or an already fallen rock, the falling rock stops immediately, whereas haven't landed on something and a new rock immediately begins falling. Fantastic. Seems fine to me. Okay, so if we get an off by 1 error, we'll notice check for that. Ah, it's only been like 45 minutes. We're making progress. Okay. Let's code up some more rocks. And turn our rock generator back on. Which rock are we? For this one, we have to remember that our current XY is there. So, when we move, if we would move left, I want to see if so if we would move left, if X is 0, we return. Otherwise, if grid if grid So we want to check this one, which is grid, oh, there's equals true. What am I doing? I don't have to. The grid is booleans. Okay, so let's see. We're moving to the left. So if x minus 1, y plus 1, or grid y plus 2 x, and that's actually probably where we should start, or this, or grid y x, right? Because this is yx, so if that one's blocked, that's this thing is here. Then we want to return, otherwise x minus minus, then we return. As to the right, so this is 6, this is 5, this is 4, so width minus 3, return, and now we need to check if grid, so x, so y plus 2, x plus 2, y plus 1, x plus 3, y, x plus 2. So we can copy this and then modify it. So grid y plus 2, x plus 2. And again with the stopped music, y plus 1, x plus 1, or x plus 3 actually. And this x plus 2, is that right? Yeah, x plus 2, x plus 3, x plus 2. These songs aren't long enough. I'm starting back up at the top. I'm getting interrupted a lot. Okay, so all that seems fine. Otherwise we do move to the right. And then int drop. If y is 0, then we want to insert ourselves, which is, spiral starts from the top to the bottom. So y, x plus 1, then we want y plus 1, x, x plus 1, x plus 2, and then y plus 2, x plus 1. Return 0. And then if you check the left one, so if yx, the middle one, y minus 1, x plus 1, or y, x plus 2, right, the height we're currently at, the two edges are going to come to that height. Yeah. Then we want to insert the same set of things and return y. Do this, return y, otherwise y minus minus, and return minus 1. Okay. Okay. Grid y plus 2, x plus 1, or y plus 1, x plus 1, grid y, x minus 1, return, otherwise just go to the left. This one, 7, or 6, 5, 4, so if this is width minus 3, let me stop, otherwise y plus 2, x plus 3, y plus 1, x plus 3, this x plus 3, is that right? X plus 2, so if there's anything in x plus 3, for all three of those things we can't move, otherwise we move to the right and return. If y is 0, okay, let's figure out what we're inserting. We're inserting yx plus 1, yx plus 2, inserting y plus 1, x plus 2, and then we're inserting y plus 2, x plus 2. And then if we would drop, if y minus 1x, if y minus 1x plus 1, or if y minus 1x plus 2, then we do this same set of insertion. That should be fine, otherwise we go down 1. So now I've got the vert rock, so we're just for here. This rock's more similar to horizontal rock than it is similar to anything else. So let's copy from there. We're almost done with the rocks. Just got one more rock. The word rock doesn't feel like a word anymore. Here is our vert rock. Okay. So move left, if x is 0, return. If grid, or grid something. And when we hit enter on this, it's formatted correctly. So grid y, x minus 1, or grid y plus 1, x minus 1, or plus 2, or y plus 3, all x minus 1, then return, otherwise this, and then otherwise we're going to make the same conditional here. But instead it's going to be x plus 1, plus 1, plus 1, plus 1 for the height, and if x is width minus 1. Right, because we're only one thick. And then to drop, if y is 0, then we just insert. And in fact, we can combine these here. If y is 0, or grid x y minus 1. Sorry, y minus 1 x. Then we just insert this, grid y, y plus 1, y plus 2, y plus 3. Almost just left this, which would have been catastrophic. Yep. Return y. There we go. Fantastic. And it's just because there's only one conditional, so we can just combine those pretty easily. And then the square rock, which I don't know what it's most similar to, but I'm going to copy it from L because it seems more similar to the weird shapes than anything else. Okay, just coding a bunch of conditionals. Okay, I'm going to save this. If we're moving on the left, if x is 0, return. Otherwise, if y plus 1, x minus 1, or if y x minus 1, return. Otherwise do this. If we're going to the right, if it's width minus 2, return. Otherwise y plus 1, x plus 2, or y x plus 2. Return, otherwise we move to the right, and when we drop, if y is 0, we insert ourselves, just grid xy. Yeah, it's those two, and then it's the same thing, but y plus 1. We should never be overlapping, and then now we want to see if grid y minus 1x or grid y minus 1x plus 1. That's pretty much it. Then we want to do the same set of insertions. We should be good. Okay. I know we should do some stuff to test it, but I honestly want to see if I just run this, what answer do I get? 2692. What should the answer be? 3068. Crap. Okay. Alright. So let's Okay, let's write a little draw function for our grid. Which you can put right after part 2. Private static void draw grid up to. We want Boolean grid and int y for int y int I equals y. I is greater than -1 minus I dot out, and then we want like for int x equals 0, x is less than width plus x. Music is not playing again. Here we go. System.out.print if grid I x system.out.print hash else. Nope. Oh, we want to do the same thing, but we want dot. Wow, it is freezing. I can barely move my hands. Dot system.out.println. There we go. And after every time we break, if debug, oh, did I not make this static? No, I did. Oh, just draw grid up to, we want grid y. And now I want private static final boolean debug equals true. Cool. So now if I attach a debugger right here and I debug, and then I play. Nope, not what I was trying to do. Okay, well, let's stop. It's showing me a lot of stuff. I just want to be able to like test it at each thing. And then at the end, draw grid up to, it's about to get done. Dot out dot print when 1 2 3 4 5 6 7, and then system.out.println. That should be cleaner. Please debug. Go to the next one, and if we go to the console, we see this, which seems fine. And now let's start comparing. Okay. Play again. Oh no, things are already wrong. What was supposed to be next? Yeah, okay, so what's the second kind of rock? The kind of rock should be a plus. Okay, so let's go down to the let's stop and rerun. Okay, first one does what we want. The second one, if we look at rock, this is a plus rock at height 3. Is that right? Okay, so let's see. New rock. 0, 1, 2, 3, 4. Okay, so first of all, that's our first problem, is that this is not, this should be y plus equals 3. This should be y plus equals 4. So y plus equals 4. And just the first one starts at 3. Oh, well, we can put this at the top and start it at -1. Y equals -1. Okay, So let's debug, stop and rerun. Ah, crap. It's still being weird. I don't know, debug, stop and rerun. Well, we didn't attach a breakpoint is our problem there. Okay, so we're here, we play through, we look at the console, we're good. We go down, we look at the rock. This rock should be a plus rock. Its Y is 4. So there's thing at 0, there's 1, 2, 3, and then there's it. Let's see if that's right. Let's go here. Go 0, 1, 2, 3. This is a 4. So this is 4, 2. So if we go into rock.move, and this is to the left, does that seem right? 1, 2, 3. Yes. So this should push to the left. So when we come out of this, now the rock is at 4, 1, and then it should fall. So its Y is 3. Which is fine. So rock.move should go to the right. It should be 3, 2 now. Perfect. Fall. 2, 2. Wonderful. So when we get to height 1 is when we should have some issues. We're good. So it should get pushed to the left. It should fall 1 unit. I is 1. So now rock.move to the right. 1, 2. And then let's step in here, which is where this should be happening. Rock.drop. Y is not 0. Okay, so let's evaluate now. The drop. So the one that should get us here is grid y minus 1, x plus 1. So first of all, what's x? This dot x is 2. Grid y minus 1, x plus 1. True. Fantastic. Because again, y is 1, so we're at 0, and then 0, 3, right? So that should be happening. So if we step over this, so grid y x plus 1 is true. Grid y plus 1. Grid y plus 1, x plus 1, x plus 2 are all true. Grid y plus 2, x plus 1 is true. Now return y. So then, now if I look at grid 0, I get false, false, true, 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 true. If I look at grid 1, I should get false, 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 true, false, false, false. If I look at grid 2, I should get false, false, true, 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 false, false. If I look at grid 3, I should get false, 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 true, false, false, false. Crap. I'm not returning the right y. That's what's happening. Return. Okay, let's stop this. Do this. Return y. So for this one, we want to return y. For the next one, we don't want to return y. We want to return, this is plus rock, right? We want to return y plus 2. For the next one, which rock is this? This is L. This also should be returning y plus 2. For the next one, vert rock, we should be returning y plus 3. Oh, and we can just see this by like the highest thing that we've written. So this should return y plus 1. So this should return 1, actually. This should return, the music turned off again. Yeah. If was 3. And let's consolidate all the y equals 0's ones. 0 or any of these. And do all this stuff, please. And we can just do the same. This one's already good. This one, just any of these. Or this. Let's add a little space so that's not awful. Yeah. Let's move this one. Or these. We shouldn't really run into y equals 0 very much, but still. These. That's horizontal rock. Okay. So let's debug again. Okay. So that's probably the problem we were having, is it was just drawing wrong. So yeah, if we go to the console now, yeah, that looks great. Okay, does that look right? Let's find out. Okay, here, here, here. That seems great. Now if we play again, we get this shape on top. That seems right. We get this shape on top. That seems right. We get this shape on top. That seems right. We get a plus on top of that. That seems right. We get an L right here. That seems right. We get hash on top of here. That seems right. Whoa, what's going on here? So this one lines up with this one fine. But then this one just like starts printing at the wrong Y. What's going on there? Y is 13? Why would Y be 13? Oh gosh. Oh no, okay. Jeez. So that's the subtle issue we're having. We're not starting high enough. Because when stuff falls on the left but the pillar is higher on the right, then we need to return that. Okay. So actually what we're going to do here, let's click stop so it stops freaking out at us. So we want so let's just start y at 3, and then we're going to figure out what we should do. We'll go int this rock's height equals y. This rock's height equals rock.drop if this rock's height does not equal -1 break if this rock's height greater than y equals this rock's height. Fantastic. So now if I set debug to false so it's not printing stuff all the time, and then I run it, what answer do I get? 2325. That somehow seems worse. Okay, actually we don't want to set this to 3. We want to set this equal to -1. That is the highest rock we've seen so far. And then we want to set this to be equal to y plus 4. Does that feel right? Yes, and then you check for this specific rock, and then you update there. Okay, so now what happens if we run? 3067. What's the right answer? Hello? 3068, so we're off by 1. Which is exactly what we want. Y plus 1. $3068. We did it. Let's just get our input. Don't care about Foul Hyper now. Fantastic. Please run again. 3100. What a nice clean number. Right answer. 1 gold star. So that took us an hour and 39 minutes. Oof. The elephants are not impressed in your simulation. They demand to know how tall the tower will be only after that many rocks have stopped. Only then will they feel confident enough to proceed through the cave. The example above the tower would be that many units tall. Okay. Basically, anytime enough of a So it can't hold all this in RAM, because how big is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. That. Thousands, millions, billions, a trillion. So that's what? A terabyte? I don't have a terabyte of RAM. Okay, so we're going to copy this. We're going to do the same exact thing. We're going to set this to be a long. We're going to set this to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that too big for a long? No, we're good. And then we're going to add a little thing. This needs to be a long. This needs to be a long. You know what? Control R. You have int written anywhere. You now need to write long. Replace all. Undo that. Okay. It's not quite going to do it for us. We need this to be long. The height that we care about. Here's my thought. It's unlikely that we're going to get, and this is a thing which I'm just going to like assume is true, is that it's unlikely that we're going to have a shaft of length. It's unlikely that we're going to have a shaft of like 3,000 or something. So when we get to 9,000, can we just like move everything down by 3,000? Just copy this stuff over into a new thing. I think we can. So this is all fine. This is going to go back to being an int. It's also going to be an int. Great. So we're good. We're good so far. The only thing that has to be along is that. Oh, jeez. Tried to move my chair, almost just completely fell. Jeez. Okay. Let me sound check again. Keeping up the grind. Oh, nice. Sorry I missed you, yes, sir. Factory crisp.ai removes echo and background noise. I should add that. My home setup is a lot better. Yeah, my bad. Oh, let's see when he said that. Jeez. That's been a long time ago. Okay, well that's not gonna help me. Oh, and 500 bits. That's so nice. When did you send this? Following since an hour ago. Oh my gosh. Can't believe I missed that. 55 minutes ago. Oh man. Okay, let's make sure we don't miss something like that again. I feel really bad. Sources, alert box, add source, add source. Alert box goes right in the middle. It's gonna be loud AF. Wonderful. Okay. So for this, 17, so that should all be fine. Yeah, and debug's gonna have to be false. Like there's no way we can draw this. So if y greater than 5,000, grid equals move down grid. Grid and y minus equals, let's call 5,000. So private static boolean array move down grid boolean array grid. Okay. Yeah. So what I want to do here is boolean array new grid equals new boolean height width for int y equals what do we want? We want to be moving down by 5,000. 5,000 y is less than height plus y for int x equals 0, x is less than width plus x. Then what I want to do is we want to go new grid y minus 5,000 x equals grid y x. And let's actually private static final int move height equals 5,000. Let's control F for 5,000. Move height. Move height. We'll just see. Okay, and then we want to return new grid. We move down y by that much. We still have the whole thing. We should be okay. And we want system.out.println. Actually, no. Let's do that for every if I is if I percent a million is 0, system.out.println done computing plus I plus gapes falling. And is a million enough? Let's go a billion. And we'll just see how long that takes. So if we run, okay, well that's because we didn't move it to part 2. Part 2, okay. Run please. I demand more music. I don't like it. Back to the top. This is taking too long. Because my temptation is honestly to just leave this running overnight. But there must be some faster way to do this. Let me think. I will sit here and try to be smart. at our CPU usage. It's not that much. And our RAM usage isn't that much either. Yeah, we can probably, well, using 58% of our RAM. What's our total amount of RAM? Let's take a look. 15 gigs. So we can like okay, let's move this down. This obviously is going to take too long, so let's stop and see if we can even get to 1,000,000 iterations. Okay, so 1,000,000's fine. How long does it take to do 1,000,000? Because we need 1,000 millions. Here, what about 10 million? Because I'm amazed that we didn't. Well, I guess it's 1,000. Stop and rerun. Let's pull up the little clock here and we can see. So we see this. 41, 2. It takes like 2 or 3 seconds to do, what is that, 100 million? 10 million? 10 million. So it takes like 20 or 30 seconds to do 100 million. So it takes like 5 minutes to do 1,000,000,000. So it's going to take 5,000 minutes to do 1,000,000,000,000. Try a little trick and see if this makes it go faster. So first of all, let's what's the like Java stopwatch? Is that what I'm looking for? Measure a lifetime using the class that a direct files the system now. Okay. Let's stop real quick and let's see if we can get a stop watch. Nope. Okay, so I've got to actually look at the build system that I'm using, which I haven't paid attention to in a long time. External libraries. Just the JDK. This is project view, packages. No, it's not helpful. Arctic files. Yeah, but how am I compiling or running any of this? Like, come on. Production. Nope. Tests. There's literally nothing. Okay, back to the project view. Oh, is it this IML file? Okay, I'm not going to worry about it. Java system clock. Abstract class clock. Where do I get one though? Okay, protected equals fixed gets own instant. Millis of the clock, okay. And that's a long, right? Yeah, long millis equals clock dot tick millis? What is all this nonsense? Are these not static methods? No. Turn the current instant using the best available system clock. Dot. I just want system default zone. So clock. Let's put this stuff. Yes. Clock equals clock dot system UTD. Sure. Should be clock dot millis. Elapsed millis since last run. New millis equals clock dot millis. This is new millis minus millis, and then I want to have millis equals new millis. Cool. So I want to do this. Let's set it to 100 million. Let's run it and let's see how long it takes. 10 milliseconds to get to there. And then I want to see if I change the size of the arrays, does it improve my stuff, which I should be able to figure out, but I kind of just want to empirically see. Now this should take about 30 seconds. Still feel bad about missing Yasser. Yeah, 26.8 seconds. Let's get one more. Let's put this in a notepad. Yeah, okay. So it takes about 26 seconds to do this. So if I take height and I add a 0, and I take move height and I add a 0, and then I take where's that 9,000? Minus height over 10. Great. Stop and rerun. First, let's see if this just destroys our RAM usage. We should be using more RAM, but we aren't. What is 100? What is 700,000 booleans? 700,000 bytes? Oh, isn't that like nothing? Yeah. Not really helping us. But now that I know that we can do more, what if we make this like... So 700 kilobytes? Yeah, let me think. Yeah. It's 100 kilobytes. We can just say 7 is 10. So this is a megabyte. This is 10 megabytes. This is 100 megabytes. This is a gigabyte. Okay, let's stop and see if that helps us at all. now does our RAM usage go up? Yes, now our RAM usage goes up because we gave it a gigabyte. Yeah, that's a lot more noticeable. Cool. We want move height to, yeah, this is gonna catch up heap space, fair enough. Height over 2. Great, so let's make this gigabyte back to 1/10 the size. Yeah, look at that. We could just give it more RAM. It didn't seem to be helping that much, but let's try it one more time. Because again, my thought is we only care about the top little part. $32 seconds. So it got worse. It's kind of surprising. Yeah, huh. A lot of RAM thrashing is happening. Okay. Let's stop this. This obviously isn't making us much faster. So what other things could make this faster? Starts how many units above? Because really what we can do is we can just move it 3 times, start it 1 higher, and then simulate. It's going to save us a lot of checks. Not that many checks, but enough. Also, am I doing the arithmetic right there? Yeah, that's right. Oh, no, but, well, I'm gonna get the wrong answer. Long, number of height adjusts equals 0. And whenever I do this, I need to do number of height adjusts plus. I need to do long height equals y plus 1. Height plus equals number of height adjusts times move height. Height is equal to height. That at least is going to help. But again, how do we get to from, like, we're so far away. I'm just straight up not seeing it. It's not impressed with the simulation. They demand to know how tall the tower will be after 1 trillion rocks have stopped. Only then will they feel confident enough to proceed through the cave. gotta be something about, like, copying. Like, does it repeat itself after a while? And it really is a trillion rocks have stopped. Let's turn debug on and look at part 1 and look at the output and see what we get. Part 1, run. It's going to print out a zillion shapes. It's all fine. All I care about is the last one, which I probably should. In fact, let's just do this. Stop. Please do this. Just draw me the last grid. And we'll see if it looks like it's repeating. Kinda looks like it does. This is tall. So if we go to levels, level 17, I want to make a new file. Level 17 output data.txt. Yes, please put this. You can get rid of this last line. And then what I want to do is, for however tall this is, I want to turn this into a string of numbers. It's going to be a little hard for me to see, but I can see whether or not the numbers do what I want. So public static look at output. Static void look at output. Let's grab this. We're going to put our level 17 output data in there. Output data. We want scanner equals new scanner. New scanner. File. Throws exception. I don't care. Well, scanner dot has next line. String line equals scanner dot next line. For int I equals 0, I is less than line dot length plus plus I. And I want int x equals 0 if line dot caret I equals hash. Then I want first what I want to do is I want to x1. I just want this to read as binary. Move to the left 1, so go up. And if this is this, x plus equals 1. And then I want to system.out.println x. And I just want to do that. Look at output. Please look at this output and print out all this stuff. Cool. So if we take this, it goes up to 2 to the 7th, which is 128. So this should go up to 156. I just want to see if there's a repeating pattern here. Let's take this. Let's put this in Notepad or something. And I want to Control F for. Let's go to the middle and see if we can find something. So Control F 102. Wrap around. Find next. 102. 8. Okay. Okay, instead of print lin, to make this a little easier, I want to print x plus dot. Okay, now run it again. Music is no longer playing. Copy this, put it in Notepad, Control F, look for 26.26.14. .8 .28 .40 .62 .60 .62 .122. Yeah, cool. So it does repeat. And now we just need to find the distance between those. So let's go, where does it start repeating? Is it going to start repeating like right here? We copy this. Cool. There, yeah, there's some weird amount at the bottom. So if we look at, what is 60.40. 60.40.60.26, which is actually just long enough for us to see the repetition. Okay, so let's try again a little further. 96.96.112.118.126. Okay, wow, we didn't put slashes instead of dots. This keyboard's a little bit jank. That's on us. This and this. Let's keep going. .28.8. Gosh darn it. Okay. Let's go a little further. 57.57.47.60.40. Yep. So let's go to the bottom line and see if this shows up. 122.52.62.63.62.4.4.110.11.58.15.56.56. Yes, that's still showing up. So if we take all this, still true. If we start from the end, if we start like here, does it repeat? Yes. So go all the way to the end. We go to like cool. So that's too far. So if we zoom in, go to here, it doesn't go like this. Okay, so it goes that far. That's I basically want to find like the periodicity of this. So let's take this. Let's actually take this and make it back to system.out.println. Because in this text editor we can do more of what we want, so please run again. I knew there was some trick like this. I wasted so much time trying to deal with other stuff. Copy this. Honestly, we can redone this whatever we want. Do this. Take like this section, so like these. Copy. No? What about like this? Copy. Okay, let's start from the top, I guess. Okay, so let's go down like here. We know this shows up in multiple places. Okay, so the periodicity 15 down to 2688. Line 15, line 2688. Is that right? Starts at line 2688. So the periodicity is 2688 minus 15 is 2673. Then we would need to figure out how many blocks it takes to like get a cycle. Okay, here's how I think we're going to solve this problem, now that I've done a little bit of analysis. So, let's take this. What I want to do now is I want to create a, all this is fine. The clock leads and whatever, like sure, that's for debugging. I want to map string integer last actually we don't even let's just try last 10 rows height. Oh no, last 10 rows check map equals new hash map. Cool. So now I need like a private static string grid to cache name. Actually, void insert. Oh no, what did I hit? Of course, grid into cache. Boolean grid int y. That's not even quite right either. I want private static string. I was right first. Get cache name from grid. Boolean grid int y for if y is less than, so we're just going to call this cache. We're already getting an arrow period to see out of that. We're going to be fine. Private static final int cache name length equals 10. We'll just see if the last 10 rows are the same, which I think should be fine. Yeah, we're not going to do any of this dumb stuff. We're also not going to do that. We're gonna have to leave some of this stuff, but we'll come back to it. So cache, cache name length, return null for int I equals 0. I is less than cache name length plus plus I. I want to do the same thing that I did for look at output, which is like this basically. Already have the line. Just instead of line length, this is going to be width. This is not going to be line.char equals hash. This is just going to be minus I x int value shift F6 value. There we go. We're gonna call this x. X is less than width, just so that it reads nicer. We probably should call this y. Can't call that y. Undo that. Y minus I, value plus equals 1, value. String, cache name equals cache name plus equals value plus this. Return cache name. Great. So now we want in the middle of this, I don't care about any of that. check the cache for periodicity. If we find it, skip all of the middle. String cache check name equals get cache name from grid y. If cache name checks not equal null, and cache dot get or default cache check name null. Default value is -1. Not equal -1. Actually, cache contains key cache check name int distance equals y minus cache dot get cache check name while I is less than a trillion long, I plus equals distance number of height adjusts plus plus I minus equals. Oh, that's not quite right. Oh, that's not quite right. That's like you need to know both the height and how many pieces had been inserted. Okay. Okay. Private class, static class, height and num bricks. Int height, int num bricks. Height and num bricks. Int height, int num bricks. This dot height equals height. This dot num bricks equals num bricks. Wow, this is just everything's getting so ugly and awful. So now this cache can't be an integer. It needs to be height and num bricks. Height and num bricks equals cached height and num bricks equals cache dot get cache check name y equals cache height and num bricks dot height. So now we need two things. We need number of height adjusts. We need the int distance of height adjust. So distance of height adjust equals this. I plus equals cache and this num bricks. Int num bricks during period equals I minus it's gonna be like almost right, so that's I starts at 0 because that's the number of bricks that have been inserted. checking to see if, as we're about to insert the ith brick within our matches, I'm just trying to figure out when do we... Okay, so if the cache is not null, then we try and grab it out, otherwise we insert it, so that's fine. So it's I minus this dot numbricks. And then this should be numbricks during period. This is long, sure. I minus equals numbricks during period. Number of height adjusts minus minus. And then I also want a boolean because I only ever want to hit the cache once. Boolean cache already hit equals false. So if we go into the cache already hit equals true. Else, if not, cache already hit because we don't want to be inserting stuff for no reason. Cache check name not equal null. Cache dot put cache check name new height and numbricks y I. Okay, that'll put it in. Should be fine. Deal with the bottom part if we do it. Height plus equals number of height adjust times distance of height adjust. Height. Cool. But part 2. Total reps. Oh yeah. Well, that's long. There we go. Should play nicer now. Okay. We straight up don't need to do this anymore. Oh, we gotta set debug to false. So I don't want to do this anymore. Let's get rid of the clock and all that nonsense. And what we want if not cache already hit and these things. Cool, so now let's debug. We should hit the cache pretty quick. Okay, beautiful. So now it should run. Go to the console. Okay, let's stop. Let's try again. The height is 14? What's going on? What did we goof up? Okay. Grid. Why? Already we're getting the wrong answer. Okay. Get cache name from grid. Y is less than cache link return. Cache name is this. I is less than this. Okay, let's stop and debug again. Y is 11. If we look at the grid, let's look at grid y minus I. False, 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 true, false, false, false. So why is value 0? Oh, well that shouldn't be value, that should be x. That's probably why. Okay, stop and rerun. You should get us an answer so fast. I mean, maybe counting to a trillion takes a long time. But like, no it doesn't. Stop and rerun. Okay, cool. So let's get rid of this. I trust it now. Continue to play. Cache is this. Cache has this size. Let's make sure we're doing stuff correctly. The distance of the height adjust is 49. The number of bricks during that period. What is I currently? 34? What's Y right now? 49? What, did something fall like all the way down the left side? Okay, let's look at oh jeez, there's a bug. We're at 49. Eight, 7, 6, 5, 4, 3, 2, 1, 40, 39, 38, 7, 36, 5. Okay, so that's we should just make the cache value longer. Let's make this 20. Let's debug again, see if that actually solves our problem. So now I've hit it at y equals 156. Okay. Wait, again, the number of bricks during the period, really? Actually, we know the period decision should be like 2000. Why don't we just insert it when we get to like 2000? That's like how far apart the height was. Stop and rerun. Now it's thinking, okay, what's the distance of the height adjust? 2673, is that what we said it would be? Yes, so that should be correct. So now if we go to this part, we added the breakpoint there. This is the part that's taking a little while. Just adding up to a trillion. Which is dumb, we could have done some math. But anyways, let's click play and then go to the console. This shouldn't take that long. What's going on? height is a negative value? That's not good. Okay, 1 second. Number of height adjusts. Long. Distance of height adjust. Long. The L's there just because it makes life feel better. Well, let's run again. Oh, and this is also, okay, well this is supposedly what it is. Let's try putting that in. I'll be surprised. You're kidding me. Whoa. Wow, okay, cool. I'm glad that I got that. I'm really tired. It's 1:45 in the morning. Okay, let's return to my advent calendar and let's check the leaderboard to see how we did. Personal stats. Yeah, 339, yeah. So 4,000 and 2,600, so like 1,700 people gave up. And we started a little over 2 hours late, 2.5 hours late. So we subtract 2.5 hours from this, and if we go look at the leaderboard for day 17, yeah, it took us like an hour, so we wouldn't have scored on the first part. And wow, people got this really fast. Impressive. Let's look at the private leaderboards. Yeah, nobody's done today's. And I don't know why I checked this one anymore, but fair enough. Okay. Yeah, this video is coming out tomorrow because I am just gonna do the little things I need to do to clean up, and I'm calling it a night. Yikes. Okay, let's just get the text. Let's get this over here. Code 17. Copy this. 2 gold stars. You'll love to see it. Okay. And unfortunately, we do need this here. So let's scroll back up to the top. Day 17, Power Classic Pro. Enter. Is there any way to collapse this? Yes, there is. Wonderful. Home device, nothing, nothing, nothing. Where this and this are necessary. We get this, and we get this. Up here, first the minus shape, then the plus shape, and so on. Once it gets to the end, it does the same thing. Rocks don't spin, blah blah blah. For example, this. In chat patterns, this means this, while this means that. Is exactly our first bold here. 7 units wide, nothing, nothing, nothing. Being pushed by a jet of hot gas. And then falling 1 unit down. Falling 1 unit down. If any movement will cause the thing, if a downward movement would cause the thing, blah blah blah. Drawing this with the @ symbol and this with the hash symbol. Jet pattern manifests as the following. This, and we get to go down for a while until we see the moment. Play some music. Wonderful. Keep going until we see to prove. This is this and this. How many units? My answer was this. Part 2. Elephants would not be impressed until they know that you can get 1 trillion rocks. What assholes. This. How tall will it be after this has happened? Your puzzle answer was this. Wonderful. Okay, I'm not even... I'll comment this code later, but let me explain what's going on and then I'm going to go to bed. So for part 1, we just needed to simulate some stuff. So we have a little rock generator to get us the next rock as we go through. If we go to our rock generator, it just cycles through the rocks for us, but it's a nice encapsulation. Take me back to where get instance happens. Thank you. Then what we do is we figure out the height where we start, which like the floor is at -1, just so that we can like use our array properly. And then just for each of the 22 rocks, just we make a new rock, we set its height equal to unclear to me why this happens this way. In fact, I think this should probably just be this. Yeah, but we make a new rock 3 units above the top of the previous rock, which is returned to us. Then we move the rock, then we update the wind direction, then we drop the rock, and then if the rock's height is not -1, then we assign. We keep track of what the highest point we've seen so far is, which is likely the rock we just dropped, but not always, because you can imagine, you know, like in Tetris, if you drop something all the way down the side. And then we output what the height is, which we're off by 1 because we use zero indexed arrays. So it's mostly just implementation, and each rock figures out whether or not it can move side to side. So for example, the horizontal rock figures out whether or not it's going to hit either the edges, or if it's going to like run into another thing that's in the row where it is. Otherwise, it just goes ahead and moves. And similarly for dropping, it figures out whether or not it's going to collide with anything, which is just a set of Boolean checks. It's relatively easy. The interesting thing is part 2, because you have to simulate 1 trillion rocks falling, which would take about 5,000 minutes, which is like between 3 and 4 days, which you could just let run, but I didn't want to because I solve all the problems. I finish it so I can go to bed. So instead what I did is I looked at the output of the first one and saw that it repeated. And says, okay, well why don't we just see how long it is until it repeats, figure out how many rocks that is, because it's not like, we know that like when the rock formation is exactly the same, like the we don't know how many rocks have fallen, so we keep track of both of those, and then what we do is when we see that it repeats, we count how many rocks there are, and we add that many rocks, and we add that much height, and then we do that over and over again until we get to just under the 1 trillion, and then we simulate the last few rocks and add up that height. And so basically we skip all of the middle. Basically we see the first time it repeats, we go, we're repeating, and then we just copy that middle part over and over again, and then we simulate the last little bit. I thought about doing some other things. I messed with RAM for a while, but this ended up being the good solution that ran relatively quickly. Again, if we run part 2 real quick. How long does it take? 1, 2, 3 seconds. Not bad for 1 trillion rocks getting simulated. You know, we'd like it to be under 1 second, but you take what you can get. All right, I think that's all I have for you guys tonight. Have a good one, everybody.